All right, this diagram should look familiar because we did this in chapter 4. If A and B are midpoints, then we know this is congruent to this, and this segment is congruent to this segment. That also tells us that AB is parallel to XZ, and we also learned that AB is half the length of XZ. So adding to that, now that we're studying proportions, we have the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, intersects the other two sides, so you have this line that's parallel to the triangle and intersects the other two sides, then it divides those sides proportionally. There's a proof on page 233, but I'm going to show you all the different ways this could be set up. So basically you have EG to GD is equal to EH is to HF. But if we label this as A and this is B, and then this side is going to be E, and then this side can be, this part will be C, this will be D, and this part will be F. Now these are different than the notes that I posted online, but very similar. They just might not be as neat. All right, so we can actually set up 6 different ratios. I'm just going to put these on here. So A is to B, A is to B, is C is to D. And then the second way you could do is A is to C as B is to D. And the third way could be A is to E as C is to F. So A is to E as C is to F. And a fourth way could be B is to D as E is to F. And the fifth way you could set it up would be B is to E as D is to F. And then a sixth way could be A is to C as E is to F. So those are 6 versions of proportions that you could set up using that diagram. Now you're not going to use them all at the same time. It's really going to depend on the information that you're given in a problem. This is kind of hard to center because I don't have the stuff set up like I did during COVID. All right, so we'll go through a couple of these and then I'll leave you some to try, and then you can look at the completed notes online and see if you got them correct. So the first one, if we know that KJ is 4 and JN is 16, and we know ML is 5, and we're looking for LN, then there's a couple different ways you can set it up. I just said 4 is to 5 as 16 is to X. And then you get 4X equals 80, so X is 20. And then in the second one, we know that MN is 42 and LN is 3. And then KN is 63, and we want to know JN. So I set this one up as 42 is to 3 as 63 is to X. And then I reduced that to 14 over 1 equals 63 over X. So 14X equals 63, so X is equal to 4.5 or 9/2. And I think I can do maybe one more without getting too messy. Let's see. So if KN is 51 and KJ is 3 and ML is 11, find MN. So I said 51 is to 3. 51 is to 3 as X is to 11. So then you would get 3X equals 561, and then divide by 3, you get X equals 187. So I'm going to leave these other three for you to try, like if we were in class, and you can work them out, and then you can go look at the completed notes that's in Schoology and compare your answers. So these are for you to do. And I don't know if the sound is recording or not, so I'm going to put you, do, and then check. So check your answers and completed notes. All right, number 7, we have triangle ABD. We know that CE is parallel to BA. We know that CB is 18. We also know that DC is 6. We know that EA is 27, and we're looking to find DE. So there's a couple different ways you can set this up. I basically said if 18 is to 27, as 6 is to X, and then you can reduce the 18 over 27 to 2/3 just to make your numbers easier. And then you can cross multiply, so you get 2X equals 18, so X is 9. And so DE is 9. Yeah, this is not the best recording, but it is what it is. If I had known everybody was going to be gone doing the PSAT, I would have went ahead and tried to cover this morning, even though I didn't feel great. All right, next problem. In triangle EFG, you know that EG is 24. And we know that EH is 8. We also know that LG is twice the length of FL. And then it says use the triangle proportionality theorem to determine if EF is parallel to HL. So that means we need to show that the sides are proportional, or the segments are proportional, and then we can say that the lines are parallel. So if we said EH is to HG as FL is to LG, could we show that those are equal, thus saying the sides are proportional, being able to say that they're parallel? So EH is 8. HG would be 24 minus 8, which is 16. FL is X, and then LG is 2X. And so when I reduce the two fractions, I get 1/2 equals 1/2. So they are equal, so the sides are proportional. So since the sides have proportional lengths, EF, or line segments EF, is parallel to HL. So if this makes sense, I don't want to have to record this like 4 times. So if I speak, I'm just going to correct myself and keep going. All right, so X, Y, and XZ are midpoints. So X, Y are midpoints, so that means this is congruent to this. And then XZ is also midpoint, so this is congruent to this. I'll use 3 lines just because it makes it stand out more. And then we also know that this is congruent to this. So what could be the value for XZ? Well, it would be the same as YT, which would be half of 23. So this one would be 11.5. So this one would also be 11.5. And then ST would be from here to here. So we know from here to here would be 9, because we know these are parallel based on if a line is parallel to one side of a triangle, it intersects the other 2 sides and it divides those sides proportionally. We also know if they're midpoints, if you recall from chapter 4, that if these are midpoints, then we also know that this line is parallel to this line in the triangle. That goes back to the page 174, the very first thing that we talked about when I started the notes. So back to this. So this would be 9. So ST would be 9 plus 9, which is 18. So we do know that this is a parallelogram because both pairs of opposite sides are congruent. So if we're looking for angle RYX, we're looking for this angle, and this is a parallelogram, then we know that these two would be supplementary. So this one is also supplementary to this one. So if 2 angles are supplementary to the same angle, then they're congruent. So this angle would be 110 degrees. And then you probably remember seeing this diagram from chapter 4 also, because I think this is the one where we did the sometimes, always, never. So if 3 lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. That was sometimes because they don't always have to be congruent, which is what we're fixing to see. But in this particular situation, if A is equal to B, then C is equal to D. That's what we did in chapter 4, and that was B from page 174. But the sometimes part, here's the other scenario. So we have a corollary that says if 3 lines intersect 2 transversals, then they divide the transversals proportionally. So now you have E is to F as G is to H, or E is to G as F is to H. Because you can check your cross products, you're still going to have E times H and F times G. All right, so in Lake Creek subdivision, the lots on which houses are built are laid out as shown. Use the distances to find W. So here's W. And so basically, you know that these are parallel and that these lots are the sides of the lot that the subdivisions are going to be built on are divided proportionally. So we could say 20 is to 25 as 24 is to W, and then that would give you 20W equals 24 times 25 would be 600. So then W would be equal to 30. And then number 11, it says find X and Y. Well, if you note here, these two are congruent by the symbols. So we know we can take 2X and set equal to X plus 8. So X would be equal to 7. So if these two are equal, then these are also equal, are congruent. So then we can say 3Y minus 5 equals 10 minus 2Y. Add your 2Y, you get 5Y. Add 5, you get 15. So Y is equal to 3. All right, last page. All right, so the last theorem says it's the triangle angle bisector theorem. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. So you'd have to be given this. You'd have to be given the notation that those are congruent, or told that the ray bisects the angle of the triangle. And so if BX bisects angle ABC, then you can say that AX is to AB as XC is to BC. Or you can actually set it up a different way. You could say AB is to BC as AX is to XC. And if you check your cross products, you can see that they're the same. So one example to go with it, if you see that this ray is bisecting this angle because you can see the congruency symbol, then you can set up your sides proportionally. So I set up 14 is to 21 as 8 is to X. You could have done 8 is to 14 as X is to 21. But you get 14X equals 168 divided by 14, and X is equal to 12. So the other way could have been 8 is to 14 as X is to 21. So you see you still have 14X equals 168, so X is still equal to 12. So you do have those options. And then the homework assignment's at the bottom of the notes, which is also on the completed notes. Good luck on the PSAT. Don't forget that if you did not try these three, to try to work those out, you might want to make you a different drawing down here so that if you've written all over this one, because it can get too messy. And then go look in the completed notes because the answers and the work is there for you as well. Hope this helps. And then when you come back on Thursday, we'll do the review and the test will be on Friday.